Hello, my friends. How are you? Today we are going to see the paper, which is the grading system based refrigeration and air conditioning. This paper is in uh, December 2020, and we start with this question: simple vapor absorption system. So this is the first time I think a question which is based on vapor absorption system is being asked, and so we are going to see this question first, and then we see later on questions. Okay. So let's start with this question. The operating system of a single stage vapor absorption refrigeration system are we have given these conditions, and we have to calculate the COP of the system. So let's first talk about what is a vapor absorption refrigeration system. A vapor absorption refrigeration system is simply a system in which we replace the compressor of a vapor refrigeration system. We have previously seen VCRS cycle. We replace in VCRS cycle we have a compressor, condenser, evaporator, and expansion valve. So what happens an expansion valve? So what happen in vapor absorption refrigeration system? We replace this compressor with a few different systems like generator, absorber, and a pump. Okay, so this is how we modify this VCRS cycle into vapor absorption refrigeration system. So first we have to calculate the COP of the system. So let's just look about a vapor absorption refrigeration system. So this is how a vapor absorption refrigeration system looks like. We replace the compressor part by this part: generator, absorber, pump, and a pressure reducing valve. Okay, so this part, this complete system is one which we replace in a vapor compression refrigeration system. This part is being replaced by a compressor. Okay, so it is a vapor compression refrigeration system, then we have compressor at this point. Okay, but since it is a vapor absorption refrigeration system, so we have a these systems present here. Okay, now we have to see what is the COP of this system. Okay, so previously you have studied the COP of a vapor compression refrigeration system is refrigeration effect divided by work done. Okay, and what is the Carnot COP? Carnot COP is equal to lower temperature divided by difference between higher temperature and lower temperature. Okay, the higher temperature is observed in condenser and the lower temperature is observed in evaporator. Okay, now what happens in the VARS cycle? The COP gets modified. So in VARS cycle, it is very important you remember the overall Carnot COP is the overall Carnot COP is the product of this COP and the COP generated due to this thing, and this actually provides us a efficiency. So what happens, the efficiency of this system is multiplied by the COP of this system. Now what if the temperature of this generator is Tg and the temperature of this absorber is Ta? Now what is the efficiency of this system? So I think you have studied in case of I think you have studied this thing in case of your thermodynamics. The efficiency of a system is T higher temperature minus T lower temperature divided by T higher temperature. Okay, so here higher temperature is Tg and lower temperature is Ta. So now what is the efficiency of this system is equal to Tg minus Ta divided by Tg. Okay. Now, the overall COP of this system is the product of this efficiency and the Carnot COP. Okay, so let me clear all this thing so that you may get understand it better. Okay, so overall the Carnot COP overall Carnot COP is equal to the product of efficiency multiplied by COP. So efficiency comes from this system and COP comes from this system. Okay, so I just draw a line. I just draw a system like this. Okay, so now this. So efficiency comes from this system and COP comes from this system. Okay, so I think now it is more clear for you. Now, what is the efficiency which is coming from this system? If it is temperature Tg and it is Ta, okay, and if it is Tc and it is Te. Now, what is efficiency from this system is Tg minus Ta divided by Tg. Okay. Now what is COP from this system is lower temperature, which is Te divided by Tc minus Te. So now what is the combined COP is equal to Te divided by Tc minus Te multiplied by Tg minus Ta divided by Tg. Okay. Now I think you know the COP of a VARS cycle. Okay. So in case your exam question comes, so you can draw this figure and explain what is vapor absorption refrigeration system, and you can drive the COP also of this system. Okay. Now we can solve this question very easily. Okay. So let me clear all this thing. So what is the COP? COP is equal to Tg minus Ta divided by Tg multiplied by Te divided by Tc minus Te. Okay, all the temperatures which are given here, you try to put them in the Kelvin. Okay, so what is the temperature at Tg? Tg is equal to 90 degrees Celsius. So what is it is in Kelvin? It is 90 plus 273. Okay, so now what is the absorber temperature and condenser temperature? Ta is equal to 40 plus 273. So you can solve this thing. What is the temperature of Tc? It is also equal to 40 plus 273. And what is Te? Te is equal to 0. So 0 plus 273. So now what is this comes? It is 273. This will come to be, let me just check. Okay, so okay, so it comes to be, let me solve it with my calculator. So this comes to be 40 plus 273. It comes to be 313 Kelvin. This is also comes in Kelvin. This is 313 Kelvin and it is 90 plus 273. So it is 363 Kelvin. Okay, so now what is COP? COP is equal to Tg is 363 minus Ta is 313 divided by Tg is 363 multiplied by Te is 273 multiplied by Tc is 313 minus 273. So okay, so you can solve it and you get what is the COP. So let me just solve it and okay, so it comes out to be 0.94. So what is the COP of the system? COP of the system is 0.94. Now what is total heat rejection from the system? Okay, so heat reject from which portion? Okay, so I hope you have noted all these things. So let me clear this thing. Okay, so see, the heat is absorbed in this system. In generator, heat is absorbed. In evaporator, heat is absorbed. Okay, and heat rejected in case of condenser, and heat reject in case of absorber. Okay, so total heat absorbed is Qg plus Qe. This is the total heat absorbed. Total heat absorbed. Now what is the value of Qg? Qg is given to us. The heat input to the system is 160 kilowatt. Okay, so we can put it is 160 plus QE. system has a refrigerating capacity means it is the heat absorbed in the evaporator. So heat absorbed in the evaporator is this much. So total heat absorbed comes out to be 260 kilowatt. Okay, so this is comes out to be total heat rejection. So whatever heat absorbed in the system will actually be get rejected. Okay, so this is the heat absorbed and this actually is the heat rejected. Okay, whatever heat absorbed in the system will actually have to be rejected. So total heat absorbed is equal to total heat rejected. So this is the amount of heat which is to be get to rejected. Okay, जितनी भी हीट एब्जॉर्ब होगी सिस्टम में उतनी ही हीट सिस्टम से रिजेक्ट होगी. तो टोटल हीट जो रिजेक्ट होगी वो किसके बराबर हो जाएगी 260 किलो वॉट. ओके. Now let us see. An inventor claims that by improving the design of the system, he would reduce the heat input to the system to 80 kilowatt. Okay. So now, what is the COP of this system? So this is the Carnot COP. You have calculated this is the Carnot COP. Now, what is actual COP? Actual COP is equal to refrigeration effect divided by heat input into the generator. Okay, so what is the refrigeration effect is equal to 100 divided by heat input in the generator is 160. So what is actual COP is 100 divided by 160. So it comes out to be 0.625. Okay. Now, what the inventor is saying, he is saying that he can design a system in such a way that he can reduce the heat input to 80 kilowatt. Okay, so what the inventor is claiming that he can design a system so that the amount of heat input to the system can get reduced. Okay, so he actually say he want to replace this 160 with 80. Okay, so we put it, and what COP we get a COP of 1.25. So what this COP is greater than the Carnot COP, and you have heard that none of the COP can be greater than Carnot COP. So the claim of this is false. Okay, इन्वेंटर ऐसा क्लेम कर रहा है कि उसने ऐसा सिस्टम बनाया है. एक्चुअली क्या है कि जितनी हमें कम यहाँ पे हीट सप्लाई करनी पड़ेगी उतना ही हमारा ज़्यादा बेनिफिट है. अगर हमें यहाँ पे बहुत ज़्यादा हीट सप्लाई करनी पड़ रही है तो इसका मतलब हमें बहुत ज़्यादा हीट जनरेट करनी पड़ रही होगी. तो बहुत ज़्यादा हीट अगर हमें जनरेट करनी पड़ेगी तो उसके लिए हमें बहुत ज़्यादा फ्यूल को स्पेंड करना पड़ेगा. तो इन्वेंटर्स जो होते हैं वो इस तरह से डिज़ाइन करते हैं सिस्टम को कि ये चीज़ कम करी जा सके. तो वही उस इन्वेंटर ने यहाँ पे क्लेम किया है कि उसने ऐसा सिस्टम बनाया है कि जो हीट इनपुट है वो कम है, वो 80 किलोवाट ही है, लेकिन ये क्लेम जो है उसका फॉल्स है. Okay, so I hope you like this question. Okay, now let's move on to another question. Okay, so you can see this question is asked in many exams. Okay, so like you can see this question is asked in ESC mechanical, in JKSSB, in ISRO, and in RPSC the same question, and you have to calculate the maximum possible COP. Okay, so always remember what is the formula of maximum possible COP. It is TG minus TC divided by TG multiplied by TE divided by TC minus TE. Okay, so this is the formula of Carnot COP for a VARS cycle. Okay, so I think you understand this thing. Now this is the second question which is asked in the exam. So this is also a very simple question. If such kind of question comes, I hope you all be able to solve this question. So in this question, the system operates on a reverse Carnot cycle. So I previously told you what is the COP of a reversed Carnot cycle. COP of a reverse Carnot cycle, it is TL divided by T TH minus TL. Okay. So now what is the lower temperature in this system is minus 15. So we put simply here minus 15. Try to put all the temperatures in the Kelvin format. Okay. TH is 35. Okay, so this is 35 minus the higher temperature is 15. So with it comes in a with a minus sign. Okay, so we can solve this and we get what is the COP for this system. So this system COP comes out to be 5.16. Okay, now what is heat rejected from the system? So actually how these systems look like, so we have a compressor here, okay, and we have a refrigerator here, ठीक है, और हमारे पास यहाँ पे क्या होता है, एक कंडेंसर होता है और एक होता है एक्सपेंशन वॉल्व, ठीक है. Okay. Heat is absorbed in this system, heat is absorbed in this system, and actually heat rejects in this system, QR. Okay. So Q1, here heat absorbed in the form of work. So total heat rejected is equal to heat absorbed in the evaporator plus heat absorbed in the compressor in the form of work. Okay. So now the capacity we have given, it is 12 ton. So capacity is actually refrigeration effect, or you can call it heat absorbed in the evaporator. So it is 12 ton. Always remember, in 1 ton how much um, kilowatt is present, it is 3.5 kilowatt present. Okay, so you simply multiply it by 3.5. So now what is it, is comes out to be 12 into 3.5, so it comes out to be 42 kilowatt. Okay, so we don't know about here QC. Okay, because so first we have to calculate power required. Okay, for calculating power required, we use this expression of COP. So COP is also equal to, COP किसके बराबर होता है, रेफ्रिजरेशन अफेक्ट डिवाइड बाय पावर रिक्वायर्ड, ठीक. Okay. So what is the power required? So power, so we can calculate power required from here. Power required is equal to, refrigeration effect is 42 divided by 5.16. Let me write it in another color so that you understand. Okay, so this is the same color. Okay, so this is power required. Power required comes out to be, so this is very simple numerical. I hope you have all solved this numerical. But just to be in the continuation, I am solving this. So it comes out to be 8.13. So what is the total heat? So this Q1 we know, this power required QC we also calculated, it is Q compressor, don't get confused, and this Q compressor is equal to work done. Okay, so don't get confused with this thing. So now what is actual, it is 42 plus 8.13. So it comes out to be 50.13 kilowatt. Okay, so now what is the power required, it is 8.13 kilowatt, and what is the heat rejected, it is 50.13. Okay. So this is the answer, and what is the COP, it is 5.16. Okay, so I request you that when you see the video, and if you find the answers to be correct, then please like that video, so that actually I come to know that my solution is correct. Okay, so अगर आप वीडियो देखते हैं और आपको वीडियो में आंसर ठीक लगते हैं, तो आप उसको लाइक कर सकते हैं, उससे मुझे समझ में आता है कि जो मेरा वीडियो है वो आंसर्स जो है वो मेरे करेक्ट हैं. And in case you find the answer incorrect, so you can simply comment it in the comment box so that I can check it. Okay, this is a request. So this is the last question which is asked in. So let me solve this question also. So this is a question we have solved many times before. So but just to be in the continuation, I am trying to solve this question. So what it is given, we have to store 15 ton of fish, and we have to calculate the COP of the plant. Okay, so actually in this question they have asked the COP, but they have not given us the refrigeration effect. Okay, so they have not given the refrigeration effect, and also they have not given the time for which the fish is actually stored. Okay, so but still we try to solve this question. We try to calculate the Carnot COP in this case. Okay, so what is Carnot COP? It is TL divided by TH minus TL. So this question also comes from unit 1. Okay, so this question is also from unit 1, and this question is from unit 3. Okay, so this question is from unit 3. So let me, so this is the lower temperature. So actually the fish is initially at 30 degrees Celsius and it has to be cooled to minus 8 degrees Celsius. So we have a fish at 30 degrees Celsius and we have to cool it up to minus 8 degrees Celsius. So what is the lower temperature here? It is minus 8 degrees Celsius. So try to put it in the form of Kelvin, divide by 30 minus minus 8. Okay, so what is the COP comes out in this? It is minus 8 plus 273 divided by 38. So COP comes out to be 6.97. Okay, so with now actually what we know, the COP is also equal to refrigeration effect divided by work done. So now what is the refrigeration effect for this system? So refrigeration effect for this system is equal to work done. They have given us if the plant require 80 kilowatt power to drive it. Okay, so we have given the work required, it is 80 kilowatt. So we simply multiply this with 80 and we can get the refrigeration effect. Okay, so we multiply this with and we get a refrigeration effect of 557.89, 557.89, and it comes in the units of kilowatt. Okay. Uh, Okay, so this is the refrigeration effect, and so the COP of the system is 6.97. Okay, it is a Carnot COP, and they have not asked about the refrigeration effect, but you can calculate it. It is 557.89. Okay, and the one last thing which we can calculate from this system is the amount of the time required, so we can calculate the time required also. So what actually, so let me uh, calculate the amount of cooling which we need. ठीक है, हम ये देख लेते हैं कि हमें कितनी कूलिंग चाहिए. अगर हमें 15 टन की फिश है हमारे पास, 15 टन फिश है हमारे पास, उसको हमें कूल करना है अप टू -8 डिग्री सेल्सियस तक, तो हमें कितनी कूलिंग चाहिए? तो वो हम कैसे निकालेंगे? 15, we simply let me solve it here. So we have actually to we have to remove three heats, q1, q2 and q3. So q1 is mc delta t is equal to 15 into 10 cube into what is the specific heat of fish? It is 2.93. So it is 2.93 into, so सबसे पहले फिश कहाँ से कहाँ तक कूल होगी? इनिशियली वो 30 डिग्री सेल्सियस पे है, पहले वो कहाँ तक जाएगी? फ्रीजिंग पॉइंट तक. तो ये हो जाएगा 30 से माइनस माइनस 4. उसके बाद फिश में क्या होगा? लेटेंट हीट चेंज होगा, तो वो कितना हो जाएगा? 15 इंटू लेटेंट हीट ऑफ फ्यूजन 235. फिर उसके बाद क्या होगा? फिश में कूलिंग होगी बिलो फ्रीजिंग पॉइंट, तो इट इज 15 इंटू 10 क्यूब इंटू we have to take the specific heat of fish below freezing point, which is given here 1.26. So we write it 1.26 into -4 minus minus 8. Okay, so we solved all these three things to get how much actually cooling we required. So let me just solve it. It comes out to be just wait, let me solve it. So it comes out to be 5.09 into 10 raised to the power 6. Okay, so it comes out to be 5.06 into 10 raised to the power 6 kilojoule. So this much amount of heat we have to removed from the system. Okay, and how much heat is removed from the system in 1 second? So this much heat is removed from the system in 1 second. एक सेकेंड में सिस्टम से कितनी हीट निकल जाती है? 557.89 किलो जूल हीट निकलती है सिस्टम से एक सेकेंड में. तो अगर हमें इतनी हीट को सिस्टम से रिमूव करना है तो कितने सेकेंड लगेंगे? तो हम क्या करेंगे, कैसे निकालेंगे? इसको डिवाइड कर देंगे 5.09 इंटू 10⁻⁶ से. 5.06 इसको डिवाइड कर देंगे, किससे डिवाइड करेंगे? 557.89 से. 557.89, तो हमें बेसिकली इतने सेकेंड लगेंगे इसको कूल करने में. ठीक है, 557.89. So we required this much second. 9.13 into 10 cube. We require this much second, or we can convert it into hours. So we require 32 hours to convert it into just wait, let me divide it by 3600. So we require 2.53 hours. Okay, so we require 2.53 hours to cool this fish. Okay, so kindly check the answers whether they are correct or not, but I think I did correctly. But in case you find any mistake, you can comment in the comment box. Okay, so let me just check it once again. Always whenever you try to solve a question in the exam, you always double check the answer. You make a habit, because in any competitive exam you go, you have to solve numericals. Okay, and in at that time there is very less time. Okay, so you have to solve a large number of numericals in very less time, so you always keep a habit of checking your numericals again and again. So um, I also try to keep my answers correct. Okay, so divide by. So I think it is correct. 2.53 hours we required to cool the fish. Okay, so the Carnot COP. So let me just clear all this thing. So what is the Carnot COP? It comes out to be 6.97. Okay, and the refrigeration effect, we always also calculated, and it comes out to be 557.89. And the time required for cooling, time required, it comes out to be 2.53 hours. Okay, so I think this is clear. So one last thing in this question is explain the working of reverse Breton cycle. Okay, so you have seen so many videos on this reverse Breton cycle. I just want to tell you like a few things. It is so in a reverse Breton cycle, in a reversed Breton cycle, in a reverse Breton cycle. So we have studied different cycles in refrigeration, like reverse Carnot cycle. So this is a reverse Breton cycle on which basically aircraft refrigeration system work. Okay, reverse Carnot cycle we have studied. So this reverse Breton cycle mostly aircraft systems run. So it has these steps. So from 1 to 2, 2 to 3, 3 to 4, this is follows. So this is isentropic compression. Okay, and this is heat rejection. This is constant pressure. This is constant pressure heat rejection, and this is isentropic expansion, and this is constant pressure heat absorption. Okay, so this is how this system work. And the compression from 1 to 2, it followed in compressor. And then in 2 say in 2 to 3, we have the heat addition. Okay, sorry, the burning takes place actually. And from 3 to 4 we have expansion takes place. And 4 to 1, we have a chamber where the absorption of heat takes place. Okay, so this is how this system works. Okay, so I think it is clear to you. Just wait, let me check one thing. Okay, so actually, this is, I think combustion is not there. This is combustion is not there. What actually happens from 2 to 3, the system, actually the temperature is dropping. So this is not the combustion. This is actually a condenser kind of process in which heat rejection takes place. Okay, so sorry, just correct it. In this, heat rejection takes place, because you can see from this diagram the temperature is dropping. So here the temperature is 2, and here the temperature is 3. Okay, so this is the cooling. And this cooling is takes place at constant pressure, and again there is an expansion, and then there is an absorption of heat. Okay, so you can drive the COP of this system is equal to the refrigeration effect divided by work done, net work done. Okay, net work done. So refrigeration effect is mainly produced in this system. So it is T1 minus T4 divided by work done, net work done. So net work done is T2 minus T1, which is work done in compression minus work done in expansion, which is T3 minus T4. Okay, so this is how you can write the COP for this system. Okay, and okay, so this is how you can write the value for this system, and you can modify this thing also, but for today I think you can keep up to this only. Okay, okay, thank you.